All right, so today we are going to start a new unit and we're going to start with composite functions. So a composite function, this is a function made of other functions. So it's composed of two functions. So this is where the output of one is the input to the other. So underneath that I have the f of g of x and f of g of x. So those are both the same thing, so they both look different, and that little O in the middle, it kind of looks like fog, but it means f of g of x. So it's both of those are the same, and they're both red, f of g of x. So it's really similar to if we look at this very first function in our table, we have f of x equals negative 3x plus 2, and listen to how we say that really quick. Again, it is f of x. So similar to that, whenever we have a composite function, it's f of g of x or g of f of x. And that tells you what the input should be. So in this is our first function. F of x is negative 3x plus 2, and g of x is x over 5. So now what we're going to do is, in place of every x in f of x, so in place of the x in negative 3x plus 2, we're going to input x over 5. So it's going to look something like this. So you can see that the negative 3 is still the same, the positive 2 is still the same, but instead of just x, I've substituted in x for the entire function g of x. So I have the entire function g of x, which is x over 5, in place of the x in f of x function. So this is f of g of x. So I'm just replacing every x I have in f of x with the entire function g of x. So now all I want to do is simplify this. So if I were to simplify this, I would just multiply, and I would end up with negative 3x over 5 plus 2. I can't simplify that anymore, so that is my composite function. All right, so let's try this next one. So we just did f of g of x, and now we want to do g of f of x. So now for every x I find in my g of x function, I want to put in the entire f of x function in place of that x. So if I were to do that, it would look like this. So you can see that my entire f of x function is substituted in for the x, and then I have the rest of my g of x function, which is over 5. So remember, especially if they're fractions, put everything that you're substituting in parentheses. That'll make your life so much easier when it comes to simplifying them. So now we don't really have to simplify this even further, but we can get rid of those parentheses because they're not really helping us. So we can just simplify it to be g of f of x is negative 3x plus 2 over 5. All right, so I'm going to do this next one, and then I'm going to have you pause the video and try the fourth one on your own. So if we're looking at this third one, we have f of x equals x squared plus 1, and g of x equals x plus 1. So now I'm in the first column and I want f of g of x. So in place of every x in my first function, I want to put the entire g of x function. So if I do that, that will give me this. Remember how I said parentheses were important? This is why. I'm still keeping that squared on the outside, but instead of x, I'm putting in x plus 1, that entire function in, and I'm putting it in parentheses. Now, if I were to simplify this, I have x plus 1 squared. So there are two different ways that we can do this. We can either multiply x plus 1 times x plus 1, or we can use Pascal's triangle to use the binomial expansion there. And so I'm going to go ahead and do that because that's a little bit of a shortcut. And so when I multiply x plus 1 times x plus 1 using Pascal's triangle, I get x squared plus 2x plus 1. and I still have that plus 1 on the outside of parentheses. So we can drop the parentheses here because we're just adding from here on out. So I'm going to simplify this further to be x squared plus 2x plus 2. All right, so now go ahead and pause the video and try g of f of x. All you're doing is for every x in your g of x function, you're going to put the entire f of x function into it. All right, so hopefully you pause the video, and for g of f of x, you should have started with this. So in place of my x in g of x, I should have my entire f of x function, which is x squared plus 1. And now all we want to do is simplify that further so we can drop the parentheses because we're just adding from here on out. And g of f of x should simplify down to x squared plus 2. All right, so let's try a couple more. So the first one, we have something that looks like FOG or FOJ. And remember, that's the same thing as the notation that we were using on the first slide. So that still means f of j of x. So up in the top right-hand corner, you have your three functions. So our function that we want to start out with is f of x, which is negative 2x plus 1. And for every x, we're going to input our j of x function. So in place of the x in f of x, we're going to substitute in 5 minus x. So go ahead and do that, and you will get negative 2 in parentheses times 5 minus x, that entire j of x function, plus 1. Now if we were to simplify this, we would need to distribute in that negative 2. So when we do that, we get negative 10 plus 2x plus 1. We can simplify this even further because we have two constants here. We have negative 10 and positive 1. So if we were to simplify this a little bit further, we could get 2x minus 9. And I just moved that 2x term to the front because we normally write our x terms first and our constants last. All right, so go ahead and again pause the video and try this next one on your own. All right, so hopefully you pause the video. Our function that we are looking for is g of j of x. So the function that we want to start with is g of x. G of x is x over 2, and we want to take the entire function j of x and substitute it in for the x in g of x. So when we do that, we should get 5 minus x, that g of x function, over 2, which finishes out our g of x function. So now we can't simplify this even further. We could drop the parentheses if we wanted to, but they really don't change either way. So we're just going to leave it like this.